Hi everyone, welcome to your channel Academy EduWorld. Today we will discuss this question paper. This exam was conducted by National Fertilizer Limited (NFL) for the post of Management Trainee Chemical Lab, and the B section of this question paper contains total 100 questions from chemistry background, and today we will discuss first 10 questions from that section. Okay, let's start. So in the first question, they are asking the electron density in a bonding molecular orbital is more in the internuclear region than at the ends. Okay, so while in an anti-bonding molecular orbital. So there are four options. Okay, so we have to take one correct answer. So like we know that in a bonding molecular orbital, electron density is more in the internuclear region. So internuclear region is a space between two nuclei. Okay, so in that space, in a bonding molecular orbital, electron density is more, but at the ends, electron density is less. But if we consider anti-bonding molecular orbitals, in that case, electron density is distributed differently compared to bonding molecular orbitals. In an anti-bonding molecular orbital, the electron density is less in the internuclear region, which is opposite of bonding molecular orbital, and more at the ends, okay, or outside the internuclear region. So it means that in the anti-bonding molecular orbitals, there is a node in the internuclear region. Okay, in that region there is zero electron density, and in antibonding molecular orbital maximum electron density is at the ends, or you can say at outside. Clear? So this difference in electron density distribution explain why the bonding molecular orbitals contribute to the stability of molecule, while anti-bonding molecular orbitals, if occupied, can destabilize the molecule. Okay, so there are four options, and in that four option, first option is low and falls to zero in the internuclear region, being maximum. So there are four options. First is low and falls to zero in the internuclear region, being maximum at the end, which is a correct option. Okay, as I said, in an antibonding molecular orbital, maximum electron density is at ends or outside. Okay, but in case of bonding molecular orbital, there is maximum electron density is in the internuclear region. So in the first question, the correct answer is A. No need to check other options. Okay, so in the second question, they are saying Cativa acetic acid process uses which metal. So if we talk about Cativa acetic acid process, in this the catalyst which is used contain iridium. Okay, so in this A option is a correct answer. The Cativa process actually uses iridium as the catalyst for the production of acetic acid. Okay, and in this actually there is a carbonylation of methanol, carbonylation of methanol to produce acetic acid, and the iridium containing catalysts are used in the Cativa acetic acid process. And this process this process is an improvement over the earlier Monsanto process, which used rhodium as the catalyst. So B option is incorrect in this case. And if we talk about the catalyst, it's mainly catalyst in the Cativa acetic acid process is iridium twice carbonyl iodide negative. So this is the catalyst that is used in the Cativa acetic acid process. So A option is correct answer in this question. In the next question, they are talking about splitting of 5 degenerate d orbitals into set of d orbitals having different energies called. So the degenerate orbital splits into two set of d orbitals of different energy that occurs according to crystal field splitting. So option correct answer is A in this case. Okay, as an example, if we talk about octahedral, in that case degenerate set of d orbitals split into two set of orbitals having different energy, one set having lower energy which is T2EG, T2G, and other is abbreviated as EG, and it is contains three orbitals and it contains two orbitals, and in the T2G set there three orbitals are dxy, dyz, and dzx, and these are dz square, dx square minus y square. So is this splitting is according to the crystal field splitting, or you can also say ligand field splitting. Okay, so A option is correct answer in this question. In the next question, fuel on incomplete combustion gives which gas? Okay, so fuel on incomplete combustion actually give carbon monoxide gas, and A option is correct answer in this question. Actually, fuel undergoing incomplete combustion typically produces carbon monoxide gas. This happens because there is not enough oxygen to fully oxidize the carbon in the fuel to convert it into carbon dioxide. Okay, and incomplete combustion can also produce other harmful substances such as soot and various hydrocarbons, and in this question the correct answer is carbon monoxide. Okay, which produces due to incomplete combustion. In the next question they are talking about titration of cyanide. Okay, titration of cyanide with silver nitrate solution. Silver nitrate solution produces silver argenate precipitates at the end point, which can be avoided with the addition of, and there are four options they are providing. First is ammonium solution, second is sodium hydroxide solution, third is potassium hydroxide, and fourth is boric acid solution. So actually what happened here, when cyanide is treated with silver nitrate, and usually in this process you will get a precipitate of silver argent argenatocyanide, and you can avoid its formation of these precipitates only when you can use ammonium solution in this case. Okay, so what will happen, if you will actually first of all you have to know its molecular formula of which is silver argenatocyanide. Its molecular formula is silver Ag cyanide twice. Okay, so this is the molecular formula of this compound, and if you want to avoid, for that you have to use ammonium solution. Ammonium ions actually helps to complex with silver ions, okay, preventing the formation of this precipitate and allowing for the clearer endpoint in this titration process. Clear? So by using ammonium solution you can avoid the formation of these precipitates. So in this case there are four options and A option is your correct answer, so you have to take A option. In the next question, to define the temperature coefficient of a reaction, the ratio of rate constants of a reaction at two temperatures should differ by. So actually in this question the correct answer is 10 degree. D option is correct answer. So to define the temperature coefficient of a reaction, okay, To define the temperature coefficient of a reaction, the ratio of the rate constant of a reaction is typically measured over a temperature interval of 10 degrees Celsius. Okay, and this coefficient indicates how the rate of reaction changes with the 10 degrees increase in temperature. So generally this is 10 degrees Celsius. So D option is your correct answer in this question. In the next question, which is correct option for 1 mole of water molecule? So if you will talk about 1 mole of water molecule, obviously it will contain 6.023 into 10 raised to power 23, which is Avogadro number. It will contain this number of molecules. Also, you know that in this only one oxygen and 1 mole has one mole of water molecule has 1 mole of oxygen atom. So A option is also correct, B option is also correct. If you talk about water, okay, so in this case there are two hydrogen, and for one hydrogen, if there is only one hydrogen in any compound, obviously in that case there will be number of atom will be equal to Avogadro number. But in this case there are two hydrogens, so that's why total number of a hydrogen atom in this case is twice of this number. Okay, so this is the total number of hydrogen atoms, and C option is also correct. And in D, this is all of these, so you have to tick D as your correct answer in this question. In the next question, they are talking about which among the following chloro derivatives has the highest boiling point. One is dichloromethane, trichloromethane, chloromethane, and tetrachloromethane. And if we talk about these four options, in this our correct option is C, which is our correct answer. So among the given chloro derivatives, carbon tetrachloride, which is tetrachloromethane, CCl4. Okay, this has the highest boiling point. Okay, actually the boiling point of a compound is influenced by its molecular weight and intermolecular forces. Molecular weight and intermolecular forces. Okay, and the tetrachloromethane has the highest molecular weight and stronger van der Waals forces compared to other listed. So these factors contribute to the higher boiling point. So these are the two factors. Okay, so in this case C option is your correct answer. In the next question, which of the following statements is true about swelling of resins? So first is high content of divinyl benzene can cause high swelling of resin. Cross-linking on decreases, increases swelling. High content of divinyl benzene causes decrease in swelling. Low content of divinyl benzene increases swelling. So out of these four options, okay, so your correct answer is C option. But according to the answer keys they are providing, maybe A is correct answer according to answer key, but that answer is incorrect. The correct answer of this question is high C, which is high content of divinyl benzene causes decrease in swelling. Actually, divinyl benzene is a cross-linking agent, and when the content of divinyl benzene in a resin increases, it leads to more cross-linking within the polymer structure. So higher cross-linking results in more rigid and less flexible network, which typically reduces the ability of the resins to swell. So conversely, a lower content of a divinyl benzene would result in less cross-linking, which can increases the swelling of the resin. So out of four options, our correct option is C. So C is our answer, due to which okay, swelling will decrease. Okay, so C is your correct answer. in 59th question. In the last question, they are talking about identify the molecular formula of an organic compound. So you have to identify the molecular formula of an organic compound with an empirical formula which is CH2. So they are providing you an empirical formula which is CH2 and its relative molecular mass is 70, and you have to find what is the molecular formula of an organic compound. And to check that, first of all you have to find ratio. Okay, you have to find ratio of relative molecular mass divided by empirical formula mass. So relative molecular mass they are already providing you, which is 70, and empirical formula mass of this CH2 which is 14. You can calculate. Okay, mass of carbon is 12 and 2 for hydrogen, so which is 14. So when you will divide 14 by 70, you will get 5. So this is a ratio. So this number you can multiply the subscript in the empirical formula CH2 by this ratio to get the molecular formula. Okay, so multiply this CH2 in with this and you will get C5H10. So C5H10 is the formula of organic compound. So in this case your correct answer is C option. So you have to take C as your correct answer. So I solved 10 questions of this B section, and I will solve other remaining questions in the next video. And if you like it, share this video and subscribe the channel. Thank you very much.